Could you talk a little bit about what circularity is, why it matters, and in what specific ways it linked to the carbon question?
Yeah. So I'll give you a very simple definition of circularity, which has worked for me very well, and that is that it's about keeping materials and resources at their highest value for as long as possible. So it's a very simple concept, but when you unpack it, it becomes obviously quite complex in terms of how you apply it and how you think about it.
Mm-hmm.
And it's one of those things that can be a little bit misused. So it can be extracted into all sorts of other things. But for me, it's about that very simple concept. And in 2016, I really wanted to explore that and apply it to the built environment and see how it would work. So I launched a project called the Circular Building, which was part of the London Design Festival in September 2016, which explored the ideas. And I got together a team in Arup to work on this and asked them to take these principles and then see them through in a project. And it was really fascinating. It was very difficult to change the mindset, first of all, to think and design in a different way. And what did it mean? One of the breakthroughs was really looking more deeply at the work of Stuart Smith, a researcher from San Francisco, not the only one, but developed the idea around shearing layers of a building.
Yes.
And he looked at how buildings learn, he called it, over time. He looked at change and what the issues were and what the problems were. And he determined that a lot of the problems were the rates of change between the different layers of the building. And so we took that diagram, the 6 S's, the layers diagram, and we used that as a very literal example of the building. And once we broke it down into layers, and then we thought, well, so we've got to think about each layer differently. We've got to design it for different perspectives and different timelines. It really opened up the way we were thinking about it. So it's a framework, and if we could put that into place, it would mean we would keep all of our materials in use, which would imply, if we collect good data, we have material passports. So basically, if we designed something to be assembled in components, we've allowed for those different layers to have different timelines so we can take them apart, change them, adapt them over time, recover the materials. I think the other thing we see is that if we're using that approach, we can be much more specific about the materials we're using. So we can start to introduce more biomaterials into the supply chain for different components and then think about where they go at the end of life. And also then another part of that is introducing materials as a service. So you're not owning the materials, but you're renting them. And for things like fit out, we talked earlier, 20% of the carbon in embodied carbon is in the fit out materials. If you can have those, perhaps not necessarily own them, but have them supplied to you as a service, then you can take them all apart and give them back to the supplier, and they can remanufacture them into something else. And we've completely transformed the picture there. So there's some very easy things we can start to work at straight away whilst we figure out some of the bigger picture items.
I see circularity as being almost a rethink of the ecosystem in which we operate, right? So it's a city scale economy question of whether there are indeed companies that are willing to take the waste from one sector and turn it into a resource for somebody else. So this is beyond what the architect or the engineer does at the drawing board. But give me an example of a few things that we can do that really will at least begin the journey towards circularity.
Yeah, so I would advocate at the moment designing everything for disassembly so you can take it apart. I would advocate good digital data so that you can record what you put into a building. And that then allows you to have material passports, which can be as simple as QR coding materials and so on, so that you can track them and recover them. And one of the problems we have at the moment, you've got very little information about the materials you're recovering. So you perhaps have to test them and recertify them and so on. So trying to eliminate that problem. And then being able to create the ecosystem in a city that will take those materials back, and it's either they get the value of the materials gets retained because there's somebody who can take them and resell them, and the logistics of that obviously need to be figured out. But that's appearing in many cities with startups doing just that, so scaling those up. And then there's also materials that can then be returned to suppliers, and a lot of manufacturers and suppliers are now embracing this idea, but it's very difficult for them to have that reverse logistics if they've been set up in a different, with a different business model. We've found this in the circular building. The plan was that we would take components from the building industry, put them together, have the prototype there for 3 weeks, and then give all the materials back to the suppliers afterwards. But a number of the suppliers didn't want the materials back. They wanted to be part of the project, but they didn't know what to do with them. It was difficult for their process. That's got to change so that windows, facades, components of buildings can go back to manufacturers. Glass manufacturers have started to realise, without a supply of glass, that they're going to struggle in business, so they want to get the glass back now. But of course, so making things like that happen through the way we design and through the way we record and store the data, and eventually the way we contract and own materials. Fantastic thing about it as well is that there's so much employment in that, and that's the economy part of circular economy.